Welcome to the third part of my document on complex numbers for the introduction to math operations. In here we're going to discuss programming the n roots of a number and look at some exercises with complex numbers. Again, if you're not interested in the programming part, you can skip this video and move on to the next one, or you can stay and watch this one where we're going to be using this document, and we go for programming the n roots of a complex number. We have an algorithm for the solution based on the example that we presented earlier on. The algorithm is this one. Given the number z and the value of n, we want to calculate the n roots of z. So first we calculate the absolute value or magnitude and the argument or angle theta for the given complex number. Then we had to produce a loop, and remember we went from 0, 1, 2 to n minus 1, and we're going to be loading a vector described by RR k plus 1 that includes the magnitude square n of, root n of r, and this value of ei theta plus 2k pi divided by n. So if we split that in a pseudocode, we have calculate this first, calculate this, then create a for loop to calculate RR sub k as indicated in here, and then return the value of RR. This is how you can program that into a function. So I'm going to do the programming here for you to follow. NC roots, that means the n complex roots of a complex number z, and for n, then we do a space bar, colon, and then we're going to add a line from the programming panel. Okay, the line here is going to need more than the two placeholders that we see in here, because we have 1, 2 right here. The for loop is a third one, and this is a fourth. So I need 4. This is what you're going to do. You're going to click on the left side of the line, and then you're going to select this and click on the, let's do it again. Click on the black button. There you go. When you have into that little arrow on a diagonal, then you can drag down your mouse to fill up the line with as many spaces that you need. And then here we go, and we say, well, I'm going to calculate R, colon, apps of Z. Click in the next placeholder and say Q, Control G, dash theta, colon equal R of Z. And then the next one we go click, and then we go to the programming menu, the programming panel, and click on the for loop. Now on the left hand side we're going to put the loop index, which is k, and then in the right hand side we're going to type this. We're going to type actually, if we were typing in text, we will type range 0 n minus 1. But when you type it in here, this is what happens. You type range parenthesis comma 0 comma 1, and then it becomes this bracket, which is equivalent to this range. And then in here we're going to put RR bracket, opening bracket, k plus 1 space bar, colon. Then we go for the n root, and then we put n at the top and r at the bottom, and space bar times e raised to the I. Okay, this is giving me some trouble. E raised to the, typically I have to type a B, I don't know, for some reason in my keyboard, and in yours probably you don't have any problem. Then type the I times parenthesis Q, Control G, plus 2 times K times P, this is a P, Control G, space bar divided by N. And now I want to take out a B. I don't use it as an auxiliary. For some reason I'm getting that strange result. And that's my RRKK, and then here I'm saying, okay, once you loaded all those values to the for loop, just report back to me that RR. And that's how I created this program. and I just repeat it here for your sake. I'm going to delete it, move this back to the center and the program is ready to be run. All what you have to do if you want to find the square root of 4 plus 3i, as we did before, just use the argument for the complex number and the second order for the square root or the cubic root of the cubic root of the number 27 right here. Now, I use it for, I'm going to calculate the 8 roots of 25. So I call NC roots with argument 25 and 8, and it gives me all these roots, which I extracted from and raised it to the 8th power to make sure that I'm getting 25 in all those results. Programming is a more detailed type of skill in SMath Studio, so we're going to dedicate some videos to show you how to do programming. The purpose of this point was just to demonstrate a small program in SMath Studio. And so the last part here is some exercises on complex numbers. I invite you to do these exercises. You can pause. I'm actually going to simplify your visualization of these. I'm going to close these and close these sections that I've opened and just show you the exercises. You can pause the video and try these exercises in your SMath Studio, and with this we conclude that document number 3, and this is the third part of it in which we present complex numbers in SMath Studio.